So I all this is Naveen. So I am a real-time faculty. So I just want to start up with what exactly a virtualization is. So let me tell you what exactly a virtualization defines. So virtualization is the creation of a virtual version of something, such as the operating system. It could be a server, or it could be a storage device, or it could be a network resources. Like wherein we are converting a physical machine into a virtual machine, and we are managing those virtual machines under one virtualized software or one virtualized server. So these servers are of different types, and these servers are manufactured with different types of vendors. So example, like who are all the vendors in the market that are providing these virtualization products? So there are four types of vendors in the market. Like first one is the VMware, second is the Red Hat Linux, third one is the Hyper-V, I mean Microsoft, and the fourth one is the Citrix. So what are all the servers that are developed by these vendors? So VMware, they have developed this ESXi server. Red Hat, they have developed this KVM. Microsoft product is the Hyper-V, and the Citrix product is the Zen server. So let me tell you what exactly the difference between all these things are. So the ESXi server is the most and the famous one in the market, wherein it has the capability of doing all these operations like vCenter operations management and host profiles and resource pools like P2V converters, like converting the physical machines to the virtual machines. So when compared to other products, so these features are not at all allowed. Like when compared with the Zen server. So as this is the competitor for this VMware right now, so Zen server is the server virtualization product developed by the Citrix. ESXi is the server virtualization product developed by the VMware people. So what exactly the difference between these two? We don't have any host profiles creations in the Zen server, whereas we have the host profile creation in the VMware ESXi server. So this is the difference. Why? Because it doesn't have the feature in it. So that's why we prefer the ESXi rather than going for the Zen server. Second thing is the resource pools. Resource pools is the one where we allocate the resources to the virtual machines. So this allocation of resources is not at all possible in the Zen server from the Citrix, whereas this allocation of resources to different types of virtual machines is done using the resource pools in the ESXi server. So this is the feature of the ESXi developed by the VMware, whereas it is not present in the Zen server. And the fourth thing, it is the P2P converter, like converting a physical machine into a virtual machine. That could be anything. So this features is converted by using the P2P converter in the ESXi, whereas this feature is not at all present in the respective of the other cases. Like Microsoft Hyper-V, it is not possible to convert the P2V like physical to virtual machines, and in the Citrix Zen server also it is not possible to convert. So these are the different types of virtualization products developed by four vendors. Okay, next thing, coming to the second module, introduction, like what exactly the vSphere suite and the ESXi servers are. Let me tell you what exactly the vSphere environment is. So in order to manage the multiple ESXi servers, so so we use the help of the vCenter server. So this vCenter server comes as a bundle along with the vSphere client, update manager, all those things. So this comes as a bundle with vSphere environment, like vSuite. We call it as vSuite. This vSuite contains vCenter server, update manager, vSphere client, and all those things, all those components. And this vCenter server, we use this to manage the multiple ESXi hosts and the virtual machines. So what exactly the ESXi server is? Let me tell you one example. Like we in the current environment, we are using only the physical machines, wherein each and every person uses each and every person uses each computer, like physical CPU, physical RAM, physical hard drive, and all those things physically. So what it does, like each and everyone using if you want around 100 or 200 or 300 physical machines, then it would be cost effective, right? Purchasing each and every CPU will be cost effective for each and every individual. So what exactly the VMware people does is, like they have developed a server called ESXi. So ESXi server is the one it will, and storage. Coming to the storage, like we are adding this ESXi host, like we are adding these virtual machines to the ESXi host, right? So where exactly this storage comes from? So in order to install the operating system on one of the virtual machine, we need to have some space, right? So this space, where it exactly comes from? So it exactly comes from the data store. So in order to install the operating systems onto a virtual machine, those operating systems should be installed on a data store. So data store is a location where it contains all the virtual machines operating system files. So this data store is created under a ESXi host. So this acts as a storage for the ESXi host. So where exactly this storage comes from, where exactly this data store comes from? It actually comes from the SAN people or the NAS boxes, SAN boxes or the NAS boxes. So how do we get this storage from? They usually allocate the LUNs to us, and these LUNs are converted as the data stores in the ESXi environment. So under this data stores, we install these operating systems and we install the virtual machines. Next thing, deploy and manage and migrate virtual machines. So deploy in the sense, if you want to deploy the virtual machine directly without installing any operating system, so we deploy these virtual machines with the help of the template. Manage in the sense, if you want to edit some configurations of the virtual machines, it could be like if you want to decrease or increase the RAM, if you want to allocate some memory to the C drive or D drive or anything like that, or if you want to add any network adapter, or if you want to add additional hard drive to the virtual machine, then we can manage using this vCenter server or ESXi server. Next, migrate the virtual machines. Migrate virtual machines is the scenario wherein if you want to perform any patching or maintenance activities on a ESXi host, so we will be migrating these virtual machines. Okay, we will be migrating these virtual machines onto another ESXi host, so that this ESXi host should be empty. It should not have any virtual machines in it. Then only we will be able to perform patching or anything like that, and after that we can migrate those virtual machines that were migrated to this ESXi host again. Okay, so what is the role of this ESXi server is, it is used to manage the virtual machines in it. So it is also used to deploy, manage and migrate the virtual machines in case of patching or anything maintenance activity which happens on the ESXi host. Next, manage user access to the virtual data center objects. Okay, we have created the virtual machines and we have installed the operating system inside it. So how do the users access those virtual machines? So we have two different types of accessing the virtual machines. One is through RDP, like each and every organization will have their own way of accessing the virtual machines. One is through RDP and one is through iConnect, wherein RDP is the general one and the iConnect is the one where we will be logging to one URL or the site, one server, wherein if we type the credentials of our Windows, it will display us like which virtual machine is allocated to you. So if we click that virtual machine, then we will be able to launch that virtual machine. This is one of the client operating system, like client virtualization. Second thing is the server virtualization, wherein if you want to access those virtual machines, we usually do it using the RDP. So how do the users have the access to launch their virtual machines? So in order to have the access, we need to add these users to the Active Directory first. So to whichever domain that virtual machine is added to that domain we need to add the users to, so that they will have the access to the virtual machines. Next thing, vCenter server to monitor resource usage. This resource usage in the sense, like we are creating the virtual machines, right, under a ESXi host. So where do these resources should come from? Like each and every operating system, let's say example, for operations, one virtual machine requires around 2 GB of RAM, 1 TB of hard drive, and it requires around 2 NIC cards, something like that. So all these resources should come from the ESXi host itself, right? So vCenter server has the capability, like it can allocate, like it can reserve some amount of memory to this virtual machine, so that none of the virtual machines will share this memory. And it can also have this limit feature using the resource pools. Like if this virtual machine needs to use only this much of memory, then it will have the capability to limit the resources. So this is the monitoring of the resource usage. Next, data protection and high availability. High availability in the sense, if the ESXi host is failed, so where do those virtual machines should go? Right? So this is the future of the cluster. We will discuss this concept in the cluster features. Next thing, update manager to apply ESXi host patches. So we will be having, like in general, we will be having monthly patches, 2 months patches or something like that. Whenever there are updates on the ESXi host, they will inform us and then we need to perform some host patches on it. So we usually do it using the update manager by using the remediation feature. Next slide. Okay, we are dealt with introduction to the virtualization. Virtual machines, as I told you, virtual machines are the ones where it contains the operating system. These operating systems could be anything, like it could be a client operating system or a server operating system. Examples for the client operating systems are Windows XP, Windows 7, Windows 8, and examples for the server operating systems are, it could be Windows 8, Windows 8 R2, Windows 2012. So what these virtual machines will have on these server operating system, we usually install some SQL servers, we usually install some Linux uses, no, not the Linux, we usually install some XenApp servers, Zen desktop servers. So along with these Windows servers, we will be also having the Linux servers, SUSE servers, Solaris servers, and all those things. So multiple operating systems can be installed on a virtual machines, and these multiple virtual machines can be managed by one single ESXi host. That is the main feature of the ESXi host. That's why it's called a virtualization product. Okay. Next, VMware vCenter server. As I told you, vCenter server, it is used to manage the ESXi host, multiple ESXi hosts, and the multiple virtual machines present inside them. And this has a feature called cluster, wherein we will deal with it in detail in the next upcoming slides. Let's configure and manage virtual networks. So in order for these virtual machines to connect to, to communicate with another virtual machines, from one virtual machine, if you want to take the RDP of another virtual machine, you need to have some virtual networking guide. So this networking is configured using the virtual NIC cards. So these NIC cards will be created from the physical NIC cards. So one physical network, for one physical NIC card will be available. So for each and every virtual machine, we will be adding a virtual switches to it. Virtual networking. Next, virtual storage. As I told you, these virtual machines will not have any physical storage present on them. This storage comes from the data store. As this data store is the virtual storage where we are creating this from the LUN. So where this LUN comes from? This LUN comes from the SAN storage box. Next, managing the virtual machine. As I told you, manage the virtual machines in the sense we can power on, power off the virtual machine. We can put the virtual machine into suspended state, anything like that. Next, data protection in the sense, like if you want to take the backups of the virtual machines, we have different types of tools. Next, access and authentication control. Okay, if you want to restrict access to this only ESXi server, we have the permissions tab in the vCenter server, wherein we can restrict access to only ESXi server or the vCenter server. Next, resource management and monitoring. As I told you, we have different types of resource pools available in the vCenter server, wherein it has three types: reservation, limit, shares. Reservation is the one wherein some amount of memory is reserved for the virtual machine. So none of the virtual machines can use this reserved memory. Next, limit is the one wherein this virtual machine should only use this much amount of memory, not more than that. Next, shares. Some virtual machines will be having a shares wherein they can share, if the two virtual machines have the 2 GB of memory, then two virtual machines will share the memory accordingly. So whichever requests more memory, they will use the more memory from those 2 GB. That is the shares. That comes under the resource pools, under the resource management. Next, high availability. As I told you, high availability is the one wherein if the ESXi server is failed, the virtual machine will be restored on another ESXi host. So wherein there won't be any downtime, there will be limited downtime. So for that thing, we will be having a concept called fault tolerance. We shall discuss it in the later slides. Next, scalability in the sense, like as I told you, each and every ESXi host is managed by vCenter server, right? So this high availability also applicable as a part of this cluster. So we can do some modifications. We can do some modification with respect to this cluster, like we can enable HA, DRS, DPM, and all those things. So this comes as a part of the scalability. Next, patch management. Patching in the sense, as I told you, like whenever there are updates on the Windows servers or ESXi servers, we usually do it using the update manager on the ESXi server, and if there are any patches to be uploaded on the Windows server, then we usually do it using the WSUS server. Next, vSphere components in the sense, while installing this vCenter server, we will be having an option like if you want to install this update manager or VMware guided consolidation or P2V converter, VMware converters, and all those things. So these are the components like VMware converter, next update manager, guided consolidation. So these are the components, additional components that comes with the vSphere suite. As I told you, like this is the VMware vSphere vCenter server suite, wherein it contains all the vSphere uh, activities. Like it could be vMotion, vSphere storage, VMware HA, fault tolerance, data recovery. So what exactly this vMotion does is like, first one, application service in the vSphere environment. What this vMotion does. So if you want to migrate these virtual machines to another ESXi host, while the virtual machine is in powered on state and while the virtual machine is being used by the user, one of the user. So we can do it without any downtime and in the power on state to another ESXi host. We can migrate a virtual machine from one ESXi host to another ESXi host while the virtual machine is being used by the user and while the virtual machine is in the power on state using the technology called vMotion. As I told you, vSphere storage, it is always from the data storage set. Next, vSphere HA is the one wherein high availability. If the ESXi host is failed, so where this virtual machines needs to be restarted on. So if this is option is enabled, then only the virtual machines will be able to restart on another ESXi host, so that there won't be any downtime. The virtual machine will be up and running. Next, fault tolerance. Fault tolerance is the one to avoid the disadvantage of this vSphere HA. Like what HA does is like it will restart the virtual machines on another ESXi host, right? So the restart duration of these virtual machines will be the downtime for the users. So while the virtual machine is being restarted, the user won't be able to access their virtual machines. They will see a connection lost to their virtual machine. They need to log in again. So in order to avoid that, we have a feature called fault tolerance technology, wherein whatever the virtual machines that are being restarted on another ESXi host, if those virtual machines are enabled with the fault tolerance, then that virtual machines will not have any downtime. So whenever a virtual machine is enabled with the fault tolerance, a duplicate copy of that virtual machine will be created on another ESXi host. Like a shadow copy will be created on another ESXi host. Okay. So when this ESXi host is failed, what happens? Then there won't be any restart of these virtual machines. So whatever the shadow copies that are present on another ESXi host for these virtual machines, those secondary virtual machines will take place of this primary virtual machines. That means those virtual machines will take over this primary virtual machines without any downtime. Okay, that is the reason why the fault tolerance technology is available, why it is being implemented. Okay, next, data recovery. In the sense, it used to take the backups using VDR, VMware Data Recovery Software. Next, vShield. This is used for the antivirus purpose. So this is the virtualization environment. Next, DRS, hot add. DRS in the sense, if you want to manage the load on the ESXi servers. Okay, if you want to, like this, these are discussed in detail in the upcoming slides. Let's go to upcoming slides. We shall discuss what exactly the definition of all these things. DRS is a load balancer. Hot add in the sense in the power on state. Next, VMware ESXi, as I told you, as I discussed. Next, DRS and DRS as I discussed. Next, VMware DPM. It is the distributed power management. It is used like whenever we want to shut down the virtual machines. If the virtual machines, I mean, whenever we want to shut down the ESXi host, when the ESXi hosts are not being used, like in the business offline hours, if those ESXi hosts are used by none of the people, then we can shut down them by automating it. Like we can enable the DPM on it, then we can schedule a activity like at this particular time that ESXi host can be shut down, so that at that particular time it should be shut down automatically. Then VMFS is the file system of the cluster whenever we create a data store. So we shall discuss it later. Like we have different types of file systems in the VMware. We shall discuss it later. Next, theme provisioning is the one wherein we are creating a hard disk for this virtual machine, right? Like while creating a virtual machine, we will be having options like to create a virtual machine with thick disk or thin disk. Okay, so if we create a virtual machine with thick disk, then that is a if you are creating a virtual machine with thick disk, then the whole hard disk will be allocated to it. Okay, it means reallocation. Next, we have different types, other type of hard disk like thin disk. It is the dynamic allocation, wherein it will allocate the memory dynamically. So if operating takes around 2 GB of memory, so if we are creating a virtual machine with 20 GB or 30 GB of memory, so this memory can be used by other virtual machines, whereas with respect to the thick disk, it cannot use. The whole disk memory is allocated to the virtual machine itself. Next, DV switch. This is the switches concept. Two types of switches we have: standard switch and the DV switch. We shall discuss in later step. Next, the certification is the VCP 5. These are certifications. There's much information required here. So in order to get certified in the VMware, we need to attend this certification exam. That's called VCP 5 for vSphere 5. Next, I have told you, like, what is a virtualization, what are the benefits of virtualization, like cost reduction. Okay. Next, ESXi installable, ESXi embedded, and the ESXi installable, embedded. Okay. Let me tell you, like, how exactly the ESXi servers are and where are these present exactly. All these ESXi servers are present in the data center itself. So these are present under this racks. Okay, how do we install the ESXi operating system onto this ESXi servers? So we connect to the ESXi servers through the different types of controllers. Like, we have different types of manufacturers for the ESXi servers. Okay. For example, we have three types of manufacturers: HP, Dell, and the IBM. These are the three hardware vendors who provide the ESXi servers. Okay. How do we install the ESXi operating system on this hardware? Okay. This ESXi server is called a bare metal product, wherein we install this ESXi server directly on the hardware without the help of the operating system. Okay. So we connect to the ESXi hardwares like HP, Dell, and the IBM through controllers. So each and every vendor will have the controllers to it. HP will have ILO, Dell we have DRAC, and IBM we have RSA. So for HP, integrated lights out. For Dell remote access controller, and for IBM it is a remote supervisor router. So these are the controllers in order to manage the ESXi server that is present in the data center, that is present in the remote location. So if you want to install the ESXi server on this type of hardwares which are present in the remote location, we usually connect to those hardwares using these controllers. If it is HP, we connect to ILO. It will have the separate IP address, separate username and the password. That is different from the ESXi IP address, username and the password. Same as the DRAC and the RSA. So after connecting to it, we would mount this ISO image, or we will ask the data center administrator to put a DVD on it, and we can start the installation from it. Next, ESXi embedded. So there are some hardwares wherein the ESXi will be installed inbuilt. Like whenever we purchase the ESXi, HP hardware, so they will install the ESXi server on it, on top of it, and they will provide to us. That's it. Next, ESXi architecture. As I told you, this ESXi architecture will have, first one is the hardware. This hardware could be HP, Dell, or IBM. On top of this hardware, we will be having the ESXi. So this is called the host operating system. So on top of this ESXi host, we will be creating the virtual machines on it. So these virtual machines will have its own hardware, will have its own guest operating system, and will have its own applications that are installed on the virtual machine. So this operation that is present on the virtual machine is called the guest operating system. So this is the architecture wherein it have one hardware, on top of it ESXi servers, on top of it the virtual machines. That's it. Next, installation of the hypervisor. We have different types of versions of the ESXi host. So these are the versions: ESX4, ESXi 4.1, ESXi 5, 5.1, 5.5. This is the latest one. 5.5 is the latest one. So what exactly is the difference between ESX and the ESXi 4.1 and ESXi 5 and all those things? So wherein here in the ESX servers we won't be able to have this features, lot of features when compared with the ESXi servers. And next thing is like this ESX server will take more memory while installation, and it takes a lot of time for the installation, whereas the ESXi takes only less time for the installation. And ESX servers will have low boot time, like slow boot time, and the ESXi servers will have faster boot time. Why? Because these ESX servers have three types of port groups, like server console, VM kernel, and the virtual machine port group. Whereas ESXi servers will have only two types of port groups, VM kernel and the virtual machine port groups. So the server console is completely removed from this ESXi server. So that's the reason the boot time is faster in the ESXi when compared to the ESX. So we have lot of differences. Like we can discuss later. Next, configure management network. Okay, this management network is the one where when we add this ESX host to the vCenter server, what are all the management agents that are involved in it? There are two types of management agents. One is VPXA and the host D. So first one is the VPXA. So it is the agent of the vCenter server which is installed on each and every ESX server. So which is managed by the vCenter server. So what type of management actions that we are performing on top of the vCenter server? So it could be like increasing or decreasing the hard disk or RAM, or making any type of changes in the cluster, like doing some vMotion. So all these activities, this agent collects all the information from the vCenter server and pass this information to the kernel of the ESX server. This is the activity of the VPXA management agent. Next is the host D agent. So these are the two management agents, VPXA and the host D. So host D agent is the agent of the ESX server. Here, like VPXA pass the information to the host D, right? So what host D does is like it pass the information to the ESX server. It acts as a middleware. That's it. Next, configure DNS and routing. So what is the DNS and routing? So how do we configure the DNS and routing? So ESXi host installation is completed, so we need to add it to the domain, right? So, and if you want to resolve the IP address with the host name, then we need to have the DNS configuration. So we usually do it by connecting to the DCUI, direct console user interface of the ESXi server, and then going to the management networking, like configuring this management networking over there, and we will be having an option called DNS configuration over there. After clicking that, we'll be having your options like enter the DNS IP address over there and all those things, host name over there. This is by using the DCUI console. And another type of configuring the DNS configuration is through connecting to the vSphere client. Connect to the ESXi host using the vSphere client and go to the configuration tab over there and click on DNS and the routing tab over there and click on properties. Then we'll be able to see like what is the name of the ESX server, what is the domain name, and where it is getting the DNS IP from. Is it getting automatically, or if you want to allocate the DNS server IP address manually to this ESXi host, you can choose by clicking the use following DNS server IP address and entering the DNS IP address over there. That's it. Next, different ways of connecting the ESX host using vSphere, using vSphere client and CLI. So in order to connect to the ESX or the ESX host, we have three ways of accessing. So we can connect through vSphere client, first one. Second thing is we can connect through PuTTY. This is the command mode interface. Then third one, it is the web browser. First, vSphere client. If you connect to the vSphere to the ESX host using vSphere client, we can perform a lot of operations. Like we can take the snapshots of the virtual machine. We can create a clones of the virtual machine. We can do a lot of activities that we cannot do using this command mode or the web browser mode. So command mode in order to troubleshoot any type of issues, like if we are taking a snapshot from this graphical, like using this vSphere client, if it is not allowing us to do, then we can take it using this command mode and command mode. Okay, and next thing is the web browser. So if you want to update this ESXi host or anything like that, we can do it manually. We can do it using the web browser and the vSphere client, but there are some limited features which cannot be happen through web browser. Next, vCenter server and installing vCenter server. So where do we install this vCenter server on? So we usually install this vCenter server on 2008 R2 servers or the 2012 servers. Next, vCenter server architecture. Let me tell you, the architecture looks like we'll be having one vCenter server over there. Under the vCenter server, we'll be having a data center. Under the data center, we'll be having a ESXi host. ESXi host. Under ESXi host, we'll be having a cluster, and cluster under cluster we'll be having a ESXi host. Under the ESXi host we'll be having the virtual machines over there. First thing is vCenter server, DC, next cluster, next ESXi host, and next virtual machines in it. Okay, this is the architecture of the vCenter server. So what are the prerequisites for the vCenter server? It requires around two like 64-bit operating systems, like 64-bit CPUs, 64-bit dual core processor. Next, what should be the speed? It should have around 2 GHz faster Intel or AMD processor. What should be the memory? Like it requires minimum of 3 GB of RAM. What should be the hard disk that it requires? It requires 3 GB of hard disk. And what is the database requirement? It should have the minimum of Microsoft SQL Server 2005, and the space requirement, it requires around 2 GB of memory to install this Microsoft server. Next, what are the different services that are provided by the vCenter server? There are a lot of services wherein it allows us to automate the provision of this virtual machines. It allows us to configure these virtual machines and the host, and it also allows us to it also provides the services like creating the resource pools and creating these virtual machines and allocating the resources to the virtual machines. And it also allows us to create the alarms and the events, like if a virtual machine is reaching this threshold, so how do we create the alarms? So this is done by using this vCenter server. It provides the service to us, and then it also provides us to schedule a task. Like if we want to migrate some virtual machines at this particular amount of time, at this particular time, then we usually do it using the task scheduler. So this is the services that are provided by the vCenter server. And what is the service that is used for this vCenter server? There is a virtual center server is the one, that is the server that should be always on, that should be always in the started mode. Next, managing vCenter server. We usually manage the vCenter server by connecting to the vCenter server through vSphere client itself. Then vCenter server data stores. And this data stores is respect to the ESXi data stores. As I told you, we created from the LUNs allocated by the SAN people. Next, adding host to the vCenter server. So in order to add the ESX host to the vCenter server, what are all the things that we need to check? Those will be checked, like with respect to the vCenter server. The vCenter server should have the upgraded version or the same version with respect to the ESX host that is added to the vCenter server. That is a minimum prerequisite to add the host to the vCenter server. Next, vCenter server events and export logs. So if we are having some issues, like if we are having some yellow triangles or red triangles on the ESXi host, then where do we check? Like it will be present in the events tab over there, and we can export the logs over there by connecting to the ESXi host through PuTTY, and then extracting the logs by using the /var/log command, /log/log /message or /log/var/log/vm kernel. So this is the location where the logs are present. Then we can export it from there. So installation of vSphere client, we usually install it on wherever the vCenter server is installed on, or we can install directly on our local desktop. Next, web client. As I told you, in order to manage this vSphere, VESS server through web browser, we need to have the web client. Next, vCenter server appliance. So wherein we are installing this vCenter server and then we are managing it through vSphere client. So wherein VCA is the one where it will be installed automatically, like it will come by default with the vCenter server. So we just deploy this VCA. That's it. That's enough. We don't need to install the vCenter server separately. That is the difference between the VCA and the vCenter server. Next, virtual machine concepts. What are the different types of virtual machines that we create? It could be Windows 7, Windows 8, Windows 2008, Windows 2008 R2 servers, Windows 2012 servers. Next, what are the different files that are involved in the virtual machine? So whenever we create a virtual machine, we will be getting different types of virtual machine files. That could be like .vmx, .vmdk, .nvram, .vmsd, .vmsset, .vmss, and .vswp. So these are different files that constitute a virtual machine. So whenever we create a virtual machine and whenever we power on a virtual machine, we will be getting these types of files. So each and every file will have each and every description. Like the .vmx is for the configuration file, .vmdk is for the hard disk file, .vmsd is for the snapshot database file. Whenever you take a snapshot, it will have the extension of .vmsd, and .vmsn is the state of the virtual machine. Whenever we take a snapshot of a virtual machine, it stores the state of the virtual machine in .vmsn file and .vmss file. So whenever we suspend a virtual machine, the state is stored in the .vmss file. .nvram, it contains the BIOS information. And next file is the .vswp. It is a swap file. It is stored with the .vswp extension. Next, VMware hardware like virtual CPU, virtual RAM, virtual disk, virtual network card, console. So all these resources can be allocated to the virtual machine from the ESXi console itself, like ESXi server itself. As I told you, we can create a number of like 2 CPUs or 4 CPUs to a virtual machine, and we can add the memory to the virtual machine. Like we can add around 4 GB, 10 GB, 20 GB. That depends on the ESXi host, and we can also increase the hard drive capability of a virtual machine that is coming from the data store, and we can add another network card to the virtual machine. Or if you want to connect to the virtual machine through another console, we can create another service console and we can connect to it. Next, creating new virtual machine, installing Windows, Linux, and Solaris operating systems in a virtual machine. As I told you, after the creation of a virtual machine is done, what type of operating system that we install on a virtual machines. Here, these are some examples that we can install on a virtual machines. So, other than this, there are a lot of operating systems and there are a lot of things that we can install on the virtual machines, like SQL servers, okay, Zen servers, Zen app servers, Zen desktop servers. So, other than this, we can install those type of servers too. That will be installed on the Windows 2008, R2, 2012 servers or anything. Then VMware tools, it acts like drivers. So like in the Windows, after the installation is completed, we need to install the drivers, right? So in the same way, after the installation of the virtual operating system inside a virtual machine is completed, so in order to avoid some disturbances like mouse dragging, mouse tracking, like the network drivers installation and graphic drivers installation, or in order to enable the copy and paste of text between the host operating system and the guest operating system, we install the VMware tools on the Windows server. So we will be explaining in detail like what exactly these tools are and how do we install them on the Windows servers and the Linux servers separately. Next, modifying VMs and how to add or remove virtual hardware. So virtual hardware in the sense, if you want to add another hard disk to the virtual machine, how do we add that? By we have the options in the edit settings of the virtual machines. Then creating the RDM for this virtual machine. So RDM in the sense, it is a raw device mapping wherein this disk is created directly from the storage box itself. It won't have any concept of the data store. The difference between data store and the RDM is like the virtual machine is always created from the data store. Like the virtual machine is always created inside the data store. So if we have the data store concept, so if we don't have the data store concept, then we have the RDM concept, wherein the virtual machine will be installed directly on the storage box itself. It won't be installed on the data store. The data store is completely eradicated. Next, CPU virtualization. What are the new features that are available in vSphere? CPU virtualization means CPU virtualization is hyperthreading. We'll discuss in the next slide. Okay, these features, networking. The networking in the virtual machines is done by using the virtual switches itself. So there are two types of switches in the VMware, like standard switches and the distributed virtual switches. So standard switch is the one for each and every virtual machine. We have different type of, for each and every virtual machine, for each and every ESXi host, we'll be having each and every switch. So whereas in the distributed virtuals, for all the ESXi hosts, we will be having only one switch, so that all the virtual machines, all the ESXi hosts will be connected to only one switch. Whereas in the standard switch, each and every ESXi host will have each and every switch to it, so that each and every ESXi host is connected to separate switches. So it will be a cost effective, right? So maintaining different types of switches for different ESXi hosts. So that's the reason we have the concept called distributed switches that came into action. Next, configuring virtual machine in Port group. Port groups are of three types. As I told you, service console port group, virtual machine port group, and the VM kernel port group. So whenever we create a virtual machine under a ASX host, to which port group that virtual machine should be allocated to. So that is always allocated to the virtual machine port group itself. So if you are not creating any port group while creating the virtual machine itself, by default it will create the virtual machine port group and it will add that virtual machine to that virtual machine port group by default without manually doing it. Next, NIC timing. NIC timing is a property of a switch wherein it contains a lot of features like load balancing, network failover detection, notify switches, and the failover. We have load balancing using different types of IP hash, source MAC hash, explicit failover, and all those things. Network failover, this network failover is done by using link status only, beacon problem. We have different options over there. We shall discuss in the switch properties later. Next, failover detection. So if one switch is when NSA is failed, so how should it explicitly fail over to another NIC card? So all these options are present inside the NSA timing in the switch properties. Next, configuring the distributed switches. As I told you, we can create a distributed switch in the ASX servers. We'll show you in the practical part over there. Next, migrating VM and VM kernel from standard switch to distributed switches. Like if you have created some port groups in the standard switch, if you want to migrate those port groups to distributed virtual switch, then we can do it by changing some settings over there. Next, using VMFS data store with ESX or ESXi. As I told you, whenever we create a data store, the data store will be automatically formatted with the VMFS file system. So there are different types of file systems. Like in the ESX, we have the VMFS3 file system. In the ESXi, we have the VMFS5 file system. Okay. So what exactly the difference between them is like there will be some block size differences between them. Wherein in the ESX, in the VMFS3 of the ESX, we have 1 MB, 2 MB, 4 MB, and 8 MB. Whereas in the ESX, only 1 MB of block size is present. Next, creating and browsing VMFS and NFS data store. So how do we create this data store? We usually create the data store after the LUN is allocated to us. So after the LUN is allocated to us, then we need to go to the configuration and the storage adapters tab of the ESX server, and then we need to click the rescan adapters over there. So whatever the LUN that is allocated from the SAN people, that is visible over there. So if you want to allocate this LUN to the existing data store, or if you want to create a data store, then go to the storage option over the configuration storage and then add storage, create a data store with respect to the LUN. If the LUN is around 200 GB or 100 GB, then we can create a data store with 100 GB or 200 GB. So if you want to extend the existing data store, so we can extend by adding the storage to the existing data store. Next, various methods to increase the size of the data store. As I told you, we can extend the data store by clicking the option called extend data store over there. Next, deleting VMFS data store. We usually don't do it in the real time, because if data store is allocated, then we won't be able to do that. We can do it, but it can be doing the command mode or anything like that, or we can do by browsing it to the data stores and checking like what are the virtual machines that are present inside them. So it will be a risk factor wherein we need to migrate all those virtual machines to another data store, not delete this data store. Next, the iSCSI software adapter is the adapter of the SAN, wherein if you want to allocate the LUNs, this LUN is allocated from this adapter itself. Next, multipathing. So in which route the packet should be sent. We have different types of multipathing technologies in the ASX server, like fixed, ground robbing, MRU. We shall discuss it later in depth. Next, load balancing. As I told you, load balancing is done using route based on originally virtual port ID, route based on IP hash, route based on MAC hash, route based on explicit failover, and all those things. Next, clones and templates. This NetApp and Clarion virtual management is from the SAN people. We are not at all involved in it. Next, clones and templates. Clone is the one which creates the exact duplicate copy of the virtual machine. Template is the one it is used for the mass deployment of the virtual machine. Next, creating templates and clones for a virtual machine. So what exactly a template does is like, so if you want to create a virtual machine, we usually do it by deploying a virtual machine from the template in the real time. So this template acts as same like the ISO file like we use in the in our day-to-day activities. In our desktop, if we want to install some operating system or anything like that, then we do it using this ISO, right? So in the same way, in the VMware, we have the template concept. From this template, we can deploy the virtual machines from this template, wherein this template is a pre-configuration, like it contains the operating system 2008 or 2 or 2012 or anything like that, or Windows 7 or Windows 8. So whenever we create a template, from the template we can create a number of virtual machines. Whereas in the clones, we can create one clone for one virtual machine itself. Next, deploying virtual machine from template. As I told you, we can deploy the virtual machine from template, or if we don't want to deploy the virtual machine from template, or if you then we can import the OVF template, wherein this OVF template will have the pre-built operating system installed on them. So we don't create any template. So it is by default presence. We can download it from the internet and we can deploy it. Next, managing virtual machines, creating, managing, and removing snapshots. As I told you, snapshots is the one wherein if you want to perform some, if you want to install some application on a virtual machine, so in order to avoid some discrepancies, like if the installation is failed, so that the impact could be on the virtual machine going corrupted or virtual machine getting shut down. So what should we do? So before installing any applications, we take a snapshot of the virtual machine. So that snapshot will be stored in this data store itself. After taking a snapshot, then we install the application on that virtual machine. So if anything goes wrong, then we can revert back to the virtual machine snapshot that we took previously. So what it does is like it preserves the state of the virtual machine. So till that time, whatever the operating systems or whatever the applications that were installed on the operating systems, that will be stored inside the snapshot. So before installing any applications, we take a snapshot. So if there is any error or if there is anything happens on the operating system, then we can revert back to the previous snapshot that we took before prior to the installation. Next migration types. Cold migration is the when we want to migrate the virtual machine in a power on state. Next, suspended state, suspended migration. If we want to migrate the virtual machine which is in the suspended state. Vmotion, when we want to migrate the virtual machine which is in the power on state. Next, storage, if you want to migrate the virtual machine to another data store. Next, enhanced vMotion is the one is advanced feature. You want to migrate the virtual machines to another ESA source from another manufacturer, which contains other processor or other processor manufacturers. vMotion is the same overall migrations. Next, resource monitoring is the resource pools. As I told you, first one, basics of CPU and memory virtualization. Multi-core process, hyper-threading, and load balancing. So multi-core process in the sense hyper-threading. Hyper-threading is the one wherein one core will act like two CPUs. So we can check the option whether the ESXi host has the hyper-threading is active or not by clicking the ESXi host and then clicking the summary tab over there. There we can check whether the ESXi host has the hyper-threading feature active or not. So if it is active, then one core will act like two CPUs. For example, if we have a dual core processor and this dual core processor has two cores in it, then this if the hyper-threading is active on it, then it will act like four virtual CPUs in it. So 2 into 2, 4 into 2, 8 virtual CPUs. So each core will act like two virtual CPUs in it if the hyper-threading is active. Next, memory virtualization. So if you want to share the memory between virtual machines, we have the technique called the TPS, transparent space sharing. Next, balloon driver. If we balloon driver is the one wherein it acts like a garbage collector. It is used to kill the pages that were unused by using the driver called VMM-EM-CTL driver. So this is used to kill the pages that were unused in the RAM by using a driver called VMM-EM-CTL by using the technology called balloon memory. Next, memory compression. As I told you, defragmentation, fragmentation, all those things. Then VM kernel swap. What should be the swap size? And what is the resource pool? Resource pool, as I told you, it is the feature wherein if you want to reserve some memory to the virtual machine or limit only this type of memory to the virtual machine and share the memory between the 2 or 3 virtual machines, then we have the concept called the resource pools. So how do we create it? How do we do it? We do it in the practical itself. Next, virtual machine, CPU, memory, I/O settings, admission control for CPU and memory. So this is the concept of this cluster. Like vCenter server uses this administrative control to ensure sufficient resources are available in their cluster to guarantee the failover for the virtual machines. This is the admission control feature. Next slide. Next, resource control and management. We have different performance monitoring methods and perform tools, performance tab over there. There we can check the performance of the ESXi host currently real-time performance, or if you want to check the ESXi host performance yesterday's or day before yesterday's or on particular days, then we can take the graph of that virtual machines in the stack graph using the performance tab over there and then exporting the graph to it and saving the graph, or else we can do the performance monitoring using the perform tool. Next is the graphs. As I told you, we can export the graphs, performance of the ESXi host through graphs. Next, access control overview, security. Like we have installed the vCenter server, and we have also created a data center, and we have added the ESXi host and to the cluster. That's it. Okay, everything is done. So how do we assign the permission to the users? Installation is done. That's completed. No. Each and every how do the users access the vCenter server? In order to access those vCenter servers, those users should be added as a administrator under this permission tab. Click on the permission tab, vCenter server permission tab, and then add the user to it and assign the permissions read and write as the administrator. Then he will be able to access the vCenter server. We will have different types of permissions to it, like if we can restrict the access to the ESXi server, or we can restrict access only to one virtual machine or anything like that. We have different types of assigning permissions. Next, alarm settings and triggers, conditional and event triggers. These are the alarms which are configured by the vCenter server itself. So if we check, like if a virtual machine reaching around CPU utilization is reaching around 90% threshold, so it should generate one alarm, right? So we can set that alarm settings in the alarm tab over there. So what should the trigger do? It should send a mail, right? So if this alarm is reached, if this threshold is reached, then we need to trigger a condition, like trigger a condition. If this condition is reached, then drop a mail to the respective users that this virtual machine has reached its threshold value. This condition is set in the triggers. Next, high availability. As I told you, high availability is the providing the high availability for the virtual machines that are present on the virtual machines. Like if the ESXi host is failed or not responding or anything like that, how do we troubleshoot? So this virtual machine should be automatically restored on another ESXi host, right? So whenever this HA is enabled on the cluster, then only it will be possible to restart the virtual machines on another ESXi host. So if it is disabled, then there is no option. Okay. Next, master and slave concepts. These are the master and slave elections happen whenever we try to add the ESXi host to the cluster. So whatever the host that is added first to the ESXi cluster, that will act as a master, and rest of the hosts that are added to the cluster, that will act as the slaves. So when the master is failed, the slave will take the position of the master. So how do we configure the vCenter HA? How do you use HA and DRS together? So these features are available in the cluster. While creation of the cluster only, we will be enabling the HA and DRS options over there. Okay, if you want to disable, then we need to uncheck the option over there. Next, NSE teaming, as I told you previously, load balancing, network failover detection, notify switches, failback. FT, as I told you, the HA will have the one disadvantage, like it will be restarting on another ESXi host, right? The restart duration will be the downtime, right? So in order to avoid that downtime, if we enable the FT on those virtual machines, there won't be any downtime. It creates a shadow copy of that virtual machine on another ESXi host. So we will be discussing like what should be the prerequisites and what are all the limitations for this FT to be enabled, and what are all the prerequisites for the HA to be enabled, and what are the prerequisites for the vMachine to done, and what are all the limitations and all those things. All these topics are covered in the in-depth classes in the upcoming classes. Next, what are DRS? As I told you, DRS is used for load balancing, wherein it looks to see that each and every ESX host has equal number of virtual machines in it. Let's say example, if the ESXi host 1 is having around 10 virtual machines in it, and if the ESXi 2 has around 2 virtual machines in it. So if these ESXi hosts are present under a cluster, and if the cluster is enabled with the DRS feature over there, then DRS will make sure that equal number of virtual machines are present on both the hosts. So the 10 virtual machines which are present on one ESX host, 2 virtual machines will be present on another ESXi host, they will be shared like 5, 10 plus 2, 12, right? So 6 will be on one ESX host, 6 will be on another ESX host. So it will do automatic migration using which technology? vMotion, as we discussed previously. Next, what are different types of affinity and anti-affinity rules? So affinity rules are the ones which keeps the virtual machine together. Anti-affinity rules are the ones which separate the virtual machines. So if you want to keep the virtual machines on ESXi host, 2 virtual machines on ESXi host, then we can set the rules over there. Then if you want to separate the virtual machines on 2 ESXi hosts, then we can set the rule over there. Update manager, as we use this update manager for the ESX patching, we do it by creating the baselines and then doing the remediation over there. Next, basic troubleshooting. How do we troubleshoot the ESXi servers? So we usually do it by connecting to the ESXi server console and then doing some modifications inside the ESX host with respect to the NIC cards, virtual machines, or anything like that. By using the ESX CLI, this is the command mode, PowerShell commands, ESX CLG. These are the commands modes that are usually acted upon the ESX host console. Next, commands related to networking. We have different types of commands related to networking, like ESX CLG NSC space -8 to display the network adapters present inside the ESX host, and all those things. All these activities are performed using these command modes. Next, as I told you, monitoring this CPU performance of the virtual machine or the ESXi host, and diagnosing the CPU performance. We usually monitor the ESX host performance using this ESX stop command. This ESX stop will display us what are all the thresholds. What are all the memory that is being utilized by the CPU, main memory, or anything like that. So we'll be discussing some troubleshooting activities with respect to the vMotion issues. Like if the vMotion is failed while migrating the virtual machine from one ESXi host to another ESXi host, if it is failed in between, how do we troubleshoot those type of issues? Next, storage vMotion issues. If you are migrating the storage like virtual machine storage from one data store to another data store, what happens if there is any error happens in between, how do we troubleshoot? Next, HA and FT issues. If the HA configuration is failed on the ESXi host, how do we reconfigure the HA, and how do we enable the FT on the ESXi host? Not on the virtual machines. Like there are some prerequisites to enable the fault tolerance and the HA, and limitations. There will be some limitations wherein only one CPU should be present for the virtual machine, not to enable the FT. Or there should not be any snapshot or anything like that. So there are a lot of limitations in order to enable the FT or HA. Scenarios of DRS issues. DRS issues means if the automatic migration is not happening, the load balancing is not happening, if the virtual machine is not able to migrate to another ESXi host, how do we troubleshoot? So those are the troubleshooting activities. There are some other issues. So as I told you, the difference between ESX and the ESXi servers. Next, BIOS and firmware upgradation on the ESXi host. So how do we do it in the real time? So in order to upgrade the ESXi host, first we need to upgrade the BIOS and the firmware of the ESXi host. This is compulsory. This is the mandatory step, because without upgrading the BIOS and the firmware, we cannot upgrade the ESXi host. And before upgrading the ESXi host, we need to check whether the vCenter has the proper version of the ESXi version or not. If not, then we need to upgrade the vCenter first, then only we can upgrade the ESXi host. Next thing, how about the monitoring the performance of the ESX host? You can monitor the CPU, memory, storage, network performance of the ESX host using the ESX stop. Next, how about the VMware converter? What exactly this converter role plays? As I told you, it is used to convert the virtual machines. It is used to convert the physical machines to the virtual machines. and virtual machines to the virtual machines. Like if you want, as I told you, P2V, V2V. P2V is done by converter, V2V is also done by the converter. So P2V is for the physical to virtual, V2V is for the virtual to virtual. Physical to virtual as everyone can understand. But what is this virtual to virtual? So if you want to migrate a virtual machine, if you want to convert a virtual machine which is present on Hyper-V to the vCenter server, like ESXi host. How do we do that? Using this virtual to virtual, or if you want to migrate a virtual machine which is present on another other ESXi server, how do we migrate that virtual machine to this virtual machine? This ESXi host. Converting that will be done using this V2V converter. Next, how do we install a 2008 R2 or 2012 R2? How do we build a server? So we'll be having a list like 100 steps wherein it contains the pre-implementation plan. Before building the servers, what are all the steps that we need to perform? What are all the steps what are all the approvals that we need to get from whom we need to get the approvals from? Then this is the pre-implementation plan. Next, implementation plan. So while installation, so what activities that we need to perform. Post installation, like what should be the antivirus that should be installed on, and what should be the IP address that should be on, and whether we need to enable the circular login on the ASS host or not, on the virtual machine or not, and check to see if the firewall should be disabled or not. All these are the post installation planning. So we have around 100 steps in it. We shall discuss in detail while build is happening or when we are building the server. Next, PSOD, purpose clean of death. So whenever the ESS host is experiencing some disconnection or not responding state, so how do we check whether this issue is restricted to the PSOD, purpose clean of death, or not? By connecting to the console directly by using the IP address of the controllers. As I told you in the starting class, in the starting slide, we connect to the console if it is HP, Dell, IBM. We connect to the consoles and check if it is PSOD, we can troubleshoot it by checking the logs over there. Next, what if the ASS host is disconnected? What are the scenarios that we can check? Check to see if the if the ASS host is powered on or not. Check to see by reconnecting the ASS host, we will be able to resolve the problem or not. Check to see by restarting the management agents on the ASX host, or check to see if the reservations are satisfied or not. All those things. Next, virtual machine not able to power on. A virtual machine may not be able to power on due to different types of scenarios. Like if there are any activities that are performing on the on the virtual machine, then it won't be able to power on. Or if there are any resource contentions on the ASX server that this virtual machine is present on, then it won't be able to power on. Or if the virtual machine is not able to power on, then the scenario is like the file required for power on in this virtual machine is not present. Like it could be share file or anything like that. If it is not present, then it won't be able to power on. Then taking the snapshot from the command mode. Using this VIM fncmd vmhpc slash snapshot.git or something like that. We have different types of commands to take the snapshots. Next, virtual machine operations. Like if you want to perform some power on, power off, or hard stop of the virtual machines using command mode, how do we do that? We have different types of commands over there. And then extending the C drive in the Windows servers. How do we do that? By allocating the disk memory from the data store and then going to the disk management over there and extending the C drive over there. Next, how do we configure the alerts to vCenter server? Like we will be discussing the ticketing tools. What are the different types of ticketing tools, and how do we allocate the tickets? How do we assign the tickets, and who should be the watchers in it? And how do we add the activity to the ticket if there is some updation on the server? This will be discussed in detail, and also the monitoring tools like alerts. Where do we get the alerts from? We get the alerts through the monitoring tools. So how do we configure the alerts to the vCenter server? So we'll be discussing like how do we set up the SMTP server over there? How do we configure this monitoring tool? How do we link the monitoring tool to the vCenter server? All those things will be discussed in detail, like ticketing tools, monitoring tools, all those things. That's it. I'm done with the completion. I'm done. I have completed the presentation. And coming to the next slide. Here it is a VMware tools installation in Linux and Windows. So how do we do the VMware tools installation? As I told you already, like what exactly these VMware tools are. As I told you, these are the drivers with respect to the Windows and the Linux. So there are different types of ways that we install on Linux operating systems in the Windows servers. So we install it by using this option called VM tab over there, and then guest tab over there, then install or upgrade the VMware tools. So if we click that tab, we click that option over there, then it will install the VMware tools automatically. As I told you, what these VMware tools are, this is the network drivers, this is the bus logic drivers, and this will enable the copy of text between the host operating system and the guest operating system, and it will also enables this mouse dragging issues, like there won't be any mouse dragging or anything like that, and the graphic drivers will be installed automatically if we do the VMware tools upgradation or installation on the Windows servers or the Linux servers. So on the Linux servers, we usually install it by using the .pl scripts over there. Next, Windows 2012 R2 build procedure. So we'll be having a separate sheet wherein, as I told you before this slide, like in the last slide, wherein we have different types of steps over the pre-implementation plan, implementation plan, and the post-implementation plan. So in the same way, for this 2012 R2 build also, we'll be having same three types of steps. It has around 100 types of steps that we need to check in order to build a 2012 server. Next, post installation steps. So the virtual machine installation is completed. So what do we need to check? As I told you, we need to check whether the firewalls should be disabled or not, whether the antivirus should be installed or not, or to check we need to add any backup ID for this backup IP address for this virtual machine or not, along with the production IP. All those things comes under this post installation steps. Next is the vMotion. So while migrating these virtual machines, if it is stopped in between, like if it is failed in between, how do we need to troubleshoot those type of issues? In order to troubleshoot those type of issues, check to see whether the vMotion presets are satisfied or not. So whether the VM kernel port is enabled or not. This is the main port group that needs to be clicked, like checked on the both ESXi host where this virtual machine migrations are happening. So if this is port is not enabled, then the vMotion won't be able to happen. This is the one scenario that we can check. There are different types of scenarios, like there should be shared storage between the ESXi servers, like between the virtual machines that are being migrated. Those virtual machines should be on the shared storage on the data store. So this is the second prerequisite. There are a lot of prerequisites that we can discuss later. Next, switch properties in detail. As I told you, there are different types of switches, like the standard switch and the distributor switch. There are different types of switch properties, like general security, traffic shaping, and the NSE teaming. Like security, in the sense, security in the security policies, we have different types of promiscuous mode, not promiscuous mode, MAC address changes, promiscuous MAC address changes, and all those things. And next, traffic shaping policies. Traffic shaping policy, we have three different options, like bus size, peak bandwidth, average bandwidth, all those things. Then as I told you, NSE timing, it had load balancing, network failover detection, notify switches, and the failback. So these are the security features: general security, traffic shaping, and the NSE timing. This comes under the standard switch properties.